So now we can look at writing an equation from the graph of a line. So on this line, I can easily see that there are 2 points, the point -9, -3, and the point 5, 4 on the graph of this line. To write an equation in point-slope form, we need to know the slope, but we also need to know a point on that line. And in this case, we have 2. So first, we actually need to calculate out our slope. And there's 2 ways we've learned to calculate the slope. We can calculate by counting right on the graph, or we could calculate it out using our slope equation, which was the change in y, so y2 minus y1 over the change in x, so x2 minus x1. Both of them should get us to the same answer. If we just count on our graph, if we use these 2 points, I'm going to calculate the rise, or the change in y, over the run, which is the change in x. So from this point, this point. So if I count up, it's 1, 2, 3, 4, 5, 6, 7. Now I'm in line with that point. So that was up. So it was an increase, or a positive 7 for my rise. Now if I count over until I hit that other point, from here to here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that was an increase of 16. So we would say that the run was a positive 16. So our slope, our number that we're putting in for m, is a positive 7/16. And if you just want to check, this is a positive slope. So if you were to picture your car on here driving up from left to right, it's increasing, it's positive. So our slope is positive. So that's the number we're going to put in place of slope for both equations. You can actually write the equation in point-slope form for either point. So if we first choose this -9, -3, my y-coordinate in place of y1 is -3. So I would list that as y minus a -3 is equal to our slope, which we calculated at 7/16. So 7/16 times x minus my x-coordinate, which is -9. And then you just want to rewrite it so that we have addition instead, because we're adding the opposite. So y minus a -3 is actually the same as y plus 3 equal to 7/16, and then x plus 9, because we're subtracting x minus a -9, adding the opposite, it's the same as x plus 9. So here's one of our equations with that first point. In our second equation, if we use this other point, 5, 4, we'll come up with an equivalent equation in point-slope form. So I'm going to plug in 4 for my y-coordinate and for y1. So using this point-slope form equation, I would have y minus my y-coordinate, so y minus 4, equaling my slope, still the same, so 7/16 times x minus my x-coordinate, which is 5. So here are the 2 equivalent equations in point-slope form. They might not look like they match the same equation because our ordered pairs are different, but if you think of the equation of this line, the graph of this line, there's infinite number of points on here. The value of these 2 equations is equivalent, and we'll learn a little bit more about that in tomorrow's lesson or the next lesson. But you can write your equation in point-slope form for any point on that line, and the slope will be the same for all of them.